Hey everybody, welcome back. We are getting closer to the end of chapter 11. We're on section 5 now, angle relationships in circles. I know we've done some of this. Let's look at it a different way. Today's I will find angle and arc measures in a circle. So the first thing that you need to do, other than having your comp book in front of you, you need to grab those two pieces of paper that you picked up today. One of them had circles written on it. Okay, so you may have gotten, that one should have been white, and then you may have gotten a pink or a white sheet as your other sheet. Okay, so you need to take these two sheets and line them up so that circles is on top and that the tangent and chord is underneath it right here. Line them up just like that so you can see it, and then turn it over and bend it down so that you make a little foldable like this. So you have 11, 5, 1, 2, and 3 right in order there. And then you can mash it down. And if you have a stapler, you can pause me and go ahead and staple that. Okay? All right, so let's go through these real quickly. All right, so the first thing we're going to do is go over the notes and formula before we do an example. So here you can have a tangent and a chord or a secant. In this case, I have tangent BC and secant BA, and they intersect at point B. Okay? So on here, notice that the angle is actually, the vertex is on the circle. That's important to notice because it'll help make it easier to memorize these a little later. So on this one, you're going to take the measure of the arc, measure of this big arc right here, and divide by 2 in order to get this angle right here. All right? And vice versa. If you have this angle, then you multiply by 2 to get the measure of this arc. Okay? Let's try an example. Up here, you have a circle and a tangent line, tangent AB, and a secant, BC. And I have given you the arc measure, this minor arc right here that measures 128 degrees, and we want to know what the measure of angle ABC is. Well, the vertex is on the circle. I've given you the measure of your arc, so all you got to do is divide by 2 or multiply by half, and you get 64 degrees. Okay? All right, let's try a different one. Let's go to the next page. Okay, this one, zoom in just a little bit for you there. Here we now have, as soon as it focuses, sorry. Here we now have two chords, okay, and we're trying to find this inside angle. Notice that the angle is inside the circle, all right, that's important. So you're going to take the two arcs, the measure of the arcs that these angles intercept. Okay, they intercept arc AB and CD. You're going to add them together and then multiply by 1/2 or divide by 2. The one thing I want you to notice, though, this is not a central angle. If this had been a central angle, then these arcs would have been congruent. But since these two chords intersect closer to one side more than the other, then the angles are still congruent because they're vertical angles, but the measurements of the arcs are different. If I had moved my intersection down this way, I would have had, an even smaller arc, but my angles would have been exactly the same. On our example here, you can pause this and write this down or draw this if you'd like. On our example, we have two secants that intersect what looks like the center, but please don't assume it's the center unless I were to say circle C, okay, or just tell you that it's at the center. Right now we have to assume it's not. So, especially since these are different if I'm given these. So what do I do to get this angle? I add the two intercepted arcs and I divide by 2. Add the two intercepted arcs and divide by 2 and you get 125.5 degrees. Okay? And then let's look at our last examples, our last notes I should say. Here, excuse me, here you have a secant and a tangent, but look where the angle is. Now it's on the outside of the circle. We had one on the circle, one inside the circle, and now on the outside. Well, this one on the circle, all you did was take the arc and divide by 2. When it was on the inside of the circle, you added the arcs and divided by 2. And now that it's on the outside of the circle, what do you think you're going to do? You take your arcs and subtract them, so it's going to be major or big arc minus little arc and divide by 2. So major minus minor divided by 2. Okay? Same thing on this one. I have two tangents. I take my major arc and subtract my minor arc and divide by 2. So big minus little divided by 2 will give me this outside angle. And it works the same way with 2 secants, where I have major, well actually this isn't a major arc, but it is the bigger arc. So a big arc minus little arc divided by 2 gives me this outside angle. Okay? So the hardest thing right now is remembering, when do I add, when do I subtract, when are they the same? Those kind of things you've got to memorize in this chapter. They won't be on the formula chart or on the test, on either the one that me or Miss Scott give you or on the star. So make sure you go back and give yourself some hints as to how to remember who goes to what. Okay? Vertex on the circle, then I take my arc and divide by 2. Vertex inside the circle, I take my arcs and add them and divide by 2. Vertex outside the circle, I subtract my arcs and divide by 2. Okay? All right, let's go over a couple examples here. You may want to go ahead and pause me so that you can get these written down. I just wrote the sections where you could find extra examples like this in the book. But this first one, you have a circle with this arc equaling 128 and this angle right here equaling 68. Okay? And then you have a circle down here where this arc right here, KH, equals 188, arc HI equals 50, and angle HJM equals 46 degrees. So if you'd like to go ahead and pause me now and do that, you can, and then we'll come back and solve for our missing pieces. All right, welcome back. Let's go ahead and solve and see what we can find here. Okay? On the first one, we want to know what angle ABE is, so we're looking for this. So remember, vertex is on the circle. What do? I just take my arc and divide by 2. Okay? Take my arc and divide by 2. So angle ABE is 64 degrees. Now I'm looking for arc BC. Well, I have an angle here, but it's not with a tangent, and I don't even know what the angle is yet. So I could figure out this arc. I've already got this arc. So if I added those and subtracted from 360, I could get this arc. So let's see. This angle is 68. If I multiply by 2, I get this arc. So let's see. 68 times 2 gives me 136 degrees. Sorry, forgot the degrees. 136 degrees. So that's arc EC. So if I do that, if I take 360 minus the 136 I just found, minus the 128, that gives me 96 degrees left for arc BC. Okay? Let's try this one. On this one, we're going to look for angle LKI. Okay? So angle LKI, where is that? That one has its vertex on the circle with a chord and a tangent. Okay? So part of the angle is outside the circle. All right, so we know that if we take this arc and we divide by 2, right, that'll give us this angle. So 188 plus 50 divided by 2 gives me 119 degrees. So angle LKI, this angle right here, is 119 degrees. Then we are going to look for the measure of this arc, IJ. Well, they gave us the measure of this angle, HJM. Okay, so in this, we have 46, okay, so 46 degrees, but this angle, it's not going to give me just this little arc because its arm reaches all the way over here. It intersects this big arc. So we need to do 46 times 2 to figure out what this full arc is. So 46 times 2 is 92, but I only want this little piece of it, okay? So 92, which is 46 times 2, that's this angle, whole arc, minus the part I already know, gives me what's left for IJ, which is 42 degrees. So please understand that when you have a chord, the vertex is on the circle and the rest of the angle is outside like this, you multiply times 2 to get the full arc that it intercepts, okay? You can kind of think of like, you know, a receiver and he goes out and grabs the football. Well, his arms go way out here and he grabs everything inside and intercepts it. So the full arc is 92, subtract the 50 because all they asked for was IJ, and you get 42 degrees. All right, that wraps up our notes for today. Please feel free to go back, review them. It only took 10 minutes for the notes, so you can review them, do anything you need to, rework anything you need to. We will do 2 or 3 more examples in class tomorrow, so please bring your questions with you. I can promise you you're not the only ones that have them, or feel free to email me or Miss Scott, and we will do our best to help you. Okay? We will see you tomorrow. Have a wonderful evening.